My name is EoinWoods. I realise if you don't know me, that's not entirely obvious unless you're from Ireland, the one country where everyone gets my name right, because I'm from Ireland originally. Leave the E off the front, pronounce the rest, that's near enough. I am chief engineer at a company called Endava. We're about 11,000 and something people in some number of countries I lose track of all the time. I've been in Endava quite a while now, longer than I ever thought I would be, which is a good sign, about 8 years, 8.5 years. Before that, I spent about 10 years building products, some of which are still running today, some of which sank without trace. But you know, that's the life of a product engineer. I then spent about 10 years working for financial companies, specifically capital markets. If you're from ING, you'll know exactly who these companies were, UBS in particular. I've always done software engineering, quite a bit of software architecture, and actually now I'm a chief engineer, not a CTO. That's updated recently. And you might know me from, I've co-authored with terrific people, some books, and written some articles, and you can find me on YouTube and all the rest. Why am I talking about architecture, though? Because I wrote my first book on software architecture years and years and years ago. Why are we still talking about it? The reason being, what did Dave Toms teach us this morning? Things change, and change all the time. And most annoyingly, if you write a book that's not easy to change, things move on. We are now in a digital age. I don't need to tell you that. Every person in the world. Are you all undergoing a digital transformation? Is it all a bit tiresome? Yes, good luck with that. I'll see you at the far end. Yeah, all it means is doing the same old inefficient things, but apparently now they're on a screen. But yeah, there's a lot of money to be made for McKinsey in it, so we just have to put up with it. We are, however, in a world where the kind of software we're developing in many cases, and by the way, I gave this talk at a research conference recently. Somebody put up their hand and said, are you talking about the sort of software that's used to control nuclear reactors and nuclear submarines? I went, oh, no. No. I think you will probably do what I do, which is develop software that fundamentally enables businesses. If you do control software for lethal weapons, I apologize, I know nothing about that, and this may not apply to you. But for everyone else, come with me on the journey. Because I think we're now being asked to build what are called platforms, as opposed to the kind of things I used to build a lot, which were standalone applications. You kind of knew what they did. Things did change all the time, but you kind of knew what they did. Whereas now, if you look at my poster child for this is Google Maps. When they started developing Google Maps, do you think the uppermost thing in the genius's mind who came up with it was, you know, I'm going to have to figure out how we do the best restaurant guide in the world. I just have a feeling that was not uppermost in his thoughts. His thought was, how on earth do I get all that map data in one place and possibly make it usable? However, because they did build it as a platform, you know, inside Google, they build all kinds of things on it, and so do people outside. Cushion.io is the app. Anyone from America? No, so you probably haven't met Cushion, neither have I practically, but it's a really interesting case study, very briefly. They built an application, whole platform, well, an application, just to help people in America claim back incorrectly charged bank and credit card fees. In Europe, that's not a thing. In America, apparently, it's massive, happens all the time. That's what they did. So they built an application, sucked in all your data from all your accounts, used machine learning on it, lots of rules. They understood all the rules from the financial institutions, used their APIs to claim back the incorrect charges. That's pretty cool. Shame was, no one cared. People kind of registered for the platform, but no one would pay for it. So they pivoted like completely different direction. And now what they are, they're a subscription management platform, because apparently managing all your subscriptions is very hard. So they help you manage your subscriptions and happen to claim back your bank charges as a bonus. And now it's been a big success. People pay for this. But you can see, if they built it as a single application thinking claim back bank charges, that would have been a hard thing to do. Because they built it thinking, we're going to have an intelligent platform that knows about bank transactions and connectivity, they were able to really change. And then, of course, Salesforce, I'm quite sure when they built that CRM, they had no idea what people would end up using Salesforce for. So what are the characteristics of these? And I think a lot of people inside enterprises today are being asked to build similar applications where you don't know the endpoint or the business problem at the beginning. They're always on, because they're often internet connected, or they support very big companies. They're built to evolve in very unpredictable ways, because now, having seen this pattern repeatedly and been surprised by it, we're smart enough to realize maybe this is just the way the world is. Generally speaking, people are expecting some intelligent behavior. They're expecting not to have to, for example, build their own machine learning service. They're sort of expecting the platform to be able to do quite clever things. It's continually being updated. One of the reasons being, as soon as you've got a platform, lots of different people want to do different things on top of it. so things are changing all the time, because even if those groups are moving at a moderate pace, put them all together, change is constant, and it's because you get a lot of parallel development. They tend, I've observed, to be highly connected. I think that's simply because platforms are expensive to build. They tend to be more valuable if they're well connected to other things. I don't think it's inherent to platforms, but a lot of them are. Because it's a platform, people want to do different things on it. They're going to need different interfaces going off to different kinds of audiences. And they must be extensible by design, otherwise no one's going to build on top of them. Oh my goodness. This is a very multi-dimensional problem, which is very difficult to solve, but more and more people are having to solve something like it. But of course, practice in software engineering doesn't stand still either. After all, we heard about the Agile Manifesto, 23, 22 years old now? Wow, a whole generation of software engineers, well, generations have grown up believing that's always been there. So Agile working, that helped us react to change. And then of course, what do the application teams do? They'd been using the infrastructure delay as an excuse for years as to why they couldn't ship every couple of weeks. Then the infrastructure guys created cloud and went, well, go on then. Ball's in your court, you can create your own infrastructure. Oh, well, when we said every 2 weeks, what we meant was quite often, maybe every 6 sprints. So we needed to get better at that. So we realized releasing small bits was better than trying to release big bits, so-called microservices. Let's just call them bits. It's a better name, really. We also, on cloud, the cloud vendors realized a lot of people building platforms needed quite sophisticated services, such as deployment and pipelines and security and machine learning and blah, blah, blah. So they realized that they could provide generic services. And why did they do that? Clearly out of the goodness of their own hearts, entirely philanthropic move. Or maybe to lock us very tightly into their platforms. You decide. You talk to the cloud vendors, it's entirely philanthropic. It's all about, have you noticed it's all about empowerment when you talk to a cloud vendor? They never seem to believe that they're locking you in. That's just an unfortunate side effect. And then, of course, the people who've been left out of the party, the operations group, who had all this change foisted on them using services that they didn't really understand, and they were not very happy. Because what's one of the things about using a reusable cloud service from an architectural perspective? You inherit all of its quality attributes, don't you? You're as reliable as it is, you're as fast as it is, you're as scalable as it is, which is sort of fine in a theoretical sense in development, we'll deal with it. If you're the operations team, who are separate and have never used a cloud service before, the fact that Dynamo can suddenly spike in latency in unpredictable ways is not something that you find very pleasant to deal with in the middle of the night when all the developers are safely asleep. So what this has resulted in is architecture being much more fluid, much more evolving than it was when I started out. I thought then it was quite difficult, but I look back now and I go, it was a lot simpler than it is today. So this means what architects do, or architecture work is going to have to change. Just a show of hands, who in the room thinks of themselves as an architect, is called an architect, works as an architect? Not that many. How many of you do architecture work? A lot more, yes, because I think I'll have a very brief, pithy slide about that later, but yeah, I think that's an important detail, is that not everyone who does architecture works as an architect. But what is the problem in this new environment? Well, I've got Adriana the architect, who is my canonical example of a good software architect, knows her stuff, very experienced, former tech lead, works with the teams very constructively, architecture work's been done, new greenfield project, everything's flowing towards operation, life is good. What happens then? We've done a couple of releases, everyone's moderately happy. Well, yeah, the business are less unhappy than they normally are, which is probably as good as it's going to get. What happens then? Well, development teams are very rarely short of an opinion or a question. So they start talking to Adriana, which is good, because they want to involve her in everything they're doing. The problem is, in the good old days, everyone was sort of doing the same thing at the same time. The release was 6 months off. It could all be managed. Now everyone wants to get something in operation in the next 3 weeks, all different days, obviously, and they've all got different questions because they're all working on different things because they've got their own backlogs, because they're empowered teams. That's exactly what we want. The snag is, if you've got one brain or one group of brains trying to manage all the complexity in the architecture, they very quickly get overloaded. And what happens, what's on the picture, everything's stopped. Well, 2 things happen. Either the architecture work gets ignored, and then you get many architectures inside one platform, and then you get a short liberating period where everyone thinks that it's all going very well, and then a sudden deceleration in velocity. We meet a lot of those projects where everyone thought it was all going very well. Velocity's gone to nearly zero, costs have gone up, and everyone wonders what's wrong. Or everyone does slow down because they realize that's the end game, so they overload the architect. The reason for this fundamentally is that if you're going to change things all the time, you don't know so much early in delivery. Again, when I started out, I've got a lot of grey hair. Forgive me. I'll tell, not quite as old as Dave, but hopefully he's not here. Oh, he is. He's at the back. A lot of grey hair. When I started out, we sort of did know the end point when we started building. Now, I don't think we do. That means we don't know so much early in delivery. There's a lot of unknowns. There always were unknowns, but there's a lot more now. That means there's a lot less value in doing architecture work, whatever that is, up front, doing it at the beginning. Perhaps there always was, but actually I don't think so. I think a lot of the systems I was building in the late 1990s, actually we did know enough to make important decisions quite early. And I'm not sure we can make so many decisions now. The approach called continuous architecture, which is kind of the underpinning for all of this waffle, is one of the emerging approaches to try and deal with these challenges. So what is continuous software architecture? The first question, which any good Scrum team would ask is, do we still need architecture? Or actually, was it a complete waste of time all the time, and do we just now stop it? As a career architect, you will not be terribly surprised to hear that I think that, yes, we do still need architecture, but I do have reasons for it. Firstly, we need to achieve quality attributes, security, performance, latency, resilience, reliability, all those things, the non-functionals, in our systems. Long experience shows us that empowered teams working on a single platform at high velocity do not accidentally achieve quality attributes. If they are secure and performant and resilient and you can evolve the platform after 2 years, they are achieving their quality attributes. They're doing something about architecture somewhere. You may not be able to find an architecture team, but there's architecture going on. Because that's almost the definition of architecture. We also need to balance stakeholder concerns. So these are all the people who care about your system. You've heard the term many times. So, some of them are positive stakeholders, end users, people paying for it. They want the system. How about all the negative stakeholders? Who's dealing with a negative stakeholder in one of their systems? Audit, compliance, business recovery group, all those people, they're at best ambivalent. At worst, you're the worst thing that's happened to them in the last 6 months because you're disrupting things and you're causing them more risk and it's something else they have to understand and they don't really care about the business outcome because they're all about whatever it is they're doing, like audit. I have observed over many years, particularly working in large financial organizations, but also years and years ago working in product groups, if there's one thing a development team does not want to do, and is typically not terribly good at, if we're honest, it's dealing with these different stakeholders. They often push it to the project manager. That's sort of okay. They probably know the people. They've got some power. But do most project managers know how to do the trade-off between security and usability? Some do. Some are, have superpowers. A lot I've met know it's got to be done, but actually can't have the detailed conversation. So balancing stakeholder concerns. Making complex trade-offs. What kind of architectural style are we going to use? Are we going to prioritize what speed are we going to go at versus maintainability? Many complex trade-offs. And there's a lot of cross-cutting stuff across the teams. Authorization and logging are probably my two favorite examples. If you leave every Scrum team, if you've got 5 Scrum teams and you ask them to do their own logging, how many logging approaches will you get? A multiple of 5. If you're very lucky, you'll get the multiple is 1. If you're really unlucky, it'll be about 3. So for the operations group, clearly this is just nonsense. I mean, the system is not supportable. And similarly, everyone's got their own approach to authentication, haven't they? Everyone's got a favorite service, everyone's got a favorite way of using it, everyone's got a favorite way of inserting it into the code, and that's a surefire way to get an insecure system. So architecture, I would believe, is important for those 3 reasons. Quality attributes, stakeholders, trade-offs. They're all cross-cutting concerns. But it's got to be a flow of decisions. There's no point trying to make all these decisions up front. We don't know enough anymore. So what does architecture work look like in the new world? It's a skill. It's not necessarily a role. It can be a role, but it's definitely a skill, and it's probably a skill we need to spread rather more widely than we did. It's a stream of decisions. It's not about creating an architecture. If you've got empowered teams and you've got fine-grained structure, I would strongly argue that creating creating definitive detailed models of every piece of the system and how they all relate to each other is a fool's errand. It's always out of date. And that's almost a truism about architecture deliverables, and it's often because they're at the wrong level of detail. So we need to decide what principles, styles, and patterns we need. We'll talk about this later. We need to delegate and share. We want to bring other people into the party. If we've got empowered teams, we've got to make sure that they can do architecture work. We need to do it little and often, because the whole point, we want to be able to adapt. And if we don't do our architecture work little and often, we can't adapt. And I think the ultimate goal is to see architecture as a shared commons. It's something the entire team believes they understand, or hopefully does understand, but certainly they feel a sense of ownership, understanding. They want to collaborate on it. They don't view it as something which years ago was really common. The architecture was seen as something that the architect did. And sort of, it's what I call the tablets of stone architecture work. Very rarely have I seen that be a success. Software architecture today has to be all about the architecture, not about the architects. So like Stefan on this stage yesterday said something along the lines of, if you've got a rubbish architecture and you document it beautifully, you've now got a documented rubbish architecture. You're no further forward. Slight simplification. Perhaps you understand it more, and that's useful, but it has no direct impact on the architecture. Back years and years ago, nearly 10 years ago now, Murat Erdar and Pierre Pura, who are my co-authors on the latest book, started having the same thoughts. I didn't know they were having the thoughts at that time. I found out about 4 years later when I talked to Murat, because we both work for banks in London. They came up with an approach called continuous architecture, which was roundly ignored by the world, despite it being almost exactly what the world needed at that moment. And the 6 principles they identified were, organize yourself around products, not projects. I know you're all going, and? Remember, they thought that in 2013. Working in large financial organizations. Those organizations were not building products back then in IT, I can assure you. But they realized early that the only way of getting empowered teams and velocity was to think about products. Focus on the quality attributes, as we've said. Scrum teams are, or good Scrum teams, empowered teams are brilliant at getting the right usable, high impact features out on time into users' hands. They're much less good at figuring out quality attributes across especially a large number of teams. Things are going to change, so let's not try and do all the decisions up front, which is a natural instinct. We want to have control, don't we? We want to manage risk and make the decisions early. We're just going to have to let go of that a bit and make them as late as we can. Of course, it's easy to say, how late is late? That is where your professional judgment as experts comes in. Architect for change, what they mean is use smaller pieces, because smaller pieces, as we know, are less risky to change. And again, another thing I think was said yesterday was software is not valuable until it's running in operation. But certainly when I started out software architecture, we didn't think much about, we maybe thought about build, we didn't think a lot about deploy and operate. So they say you've got to build it, test it, deploy it, and operate it. And that is why, actually, when Nick Rosansky and I wrote our book, we realized the mistake we'd been making. We have a development view that talks about build and test, and an operational view that talks about deploy and operate. So I'm not suggesting these are brand new ideas, but how many teams do you work in where the architectural thinking is mainly about the structure of the software, and no one's really thinking about deployment until they actually have to do a deployment? And the last one is to acknowledge. It's sort of Conway's law, which I think is probably misquoted all the time, but modeling the organization of the teams after the structure of the software you'd like. Don't make the two fight against each other. We don't say much more about that other than say, team topologies, that's a nice idea, that seems to work well. We're not organizational experts, and we're absolutely not, but we do acknowledge that the two have a strong relationship. So, it's worth just acknowledging, because I didn't create these, so I can say this. Back in 2013, those were quite a visionary set of principles to come up with, which, as I say, got largely ignored because they're not independent consultants who fly around the world talking at conferences all the time. But the ideas are now quite old, and they both used them in very large financial institutions very successfully while they were writing the book and since. So, you know, they have been battle tested. So how does it look? Well, I think until relatively recently, a lot of software development looked a bit like this, was that you have stakeholder concerns. Like people want stuff, and they all want different stuff, as you all know. Architecture is largely up front. Certainly, if you look at the software systems architecture book that I wrote with Nick Rosansky, in that book, because when we wrote it, we are assuming a lot of architecture work is done up front. So I characterize that as a blueprints approach. I mean, they're not really blueprints, but you know what I mean. Decisions are made early, people try and have comprehensive representations of all the moving parts, and try and create a walking skeleton, and then largely we do disciplined, iterative delivery. We might call it agile, or we might call it iterative, inside that loop. And we always acknowledge that there'll be architectural change, but in our subconsciouses we're thinking, I hope it's not too big, because I've kind of worked that bit out, and I'm really hoping not to revisit all that nightmare again. Which, of course, if you don't know where your platform's going, is a bit of a problem. Continuous architecture looks nearly the same when you write it down, but it's actually quite different. We just acknowledge that doing lots of blueprinting up front is probably not valuable anymore. So we just insert architecture into the development cycle, meaning we do architecture work every sprint. Not the same amount every sprint, but we do architecture work almost every sprint. But what is different is what we try and produce. We generate two sorts of output. Architectural knowledge, and that can include a model, or many models. It just depends what's useful. The reason we call it knowledge and not models is because often there's a lot more than models, and in some cases, models are almost entirely useless. It just depends on what information people need to understand the architecture they've got and to take it forwards. But what's really important, this is why we take it out of knowledge and make them distinguished, is understanding what decisions we made, because architecture is fundamentally a decision-making process. So we make decisions our first-class deliverable, and I must admit, I heard this from a software architecture researcher, an academic called Jan Bosch, who if you are on LinkedIn, you may well have seen Jan Bosch. He's very, very prolific. He told me, well, in fact, he told a whole software architecture conference in at least 15 years ago that we had entirely missed the point, and it was all about the decisions. I think we all went, eh. And what do you know? It turns out he was right. We actually always had the decisions there, but they were hidden inside the models that we were so keen on getting exactly right, despite repeated experience that actually they often weren't exactly right. I should also, particularly as I'm in the Netherlands, Dutch people in the room, please forgive my pronunciation. My thinking on this, a lot of people's thinking on this, actually goes back to a Dutch software architect called Elcho Poort. I knew I'd butcher it, I'm sorry, let's move on. Elcho is a VP level architect leader at CGI and has been there for many, many years, still lives in the Netherlands. His work on risk and cost-driven architecture, which is actually a product of CGI now, which is one of the reasons perhaps you don't see it out so much, but he's talked at this conference, I know. Elcho's work is actually the original, as in how do you drive architecture using risk and cost, which is really why we want to make it very adaptive. So I acknowledge him here, look him up. So the way that time moves is that timeline to try and map architectural effort comes from my work with Nick Rosansky. So I take full responsibility for it. In my defense, in 2011, I think it was accurate enough. It's changed now to continuous focus through the architectural life cycle. And this is what I mean by every sprint. But you'll notice it's not flat. That would be completely theoretical that the architecture work was the same in every sprint. First couple of sprints, apparently I'm meant to be in a meeting for preparing for an investor call, which is perfectly true, I am. We're talking to them this afternoon. First couple of sprints, there's loads and loads of architecture work. Perhaps after 3 or 4 sprints, there's not that much because it's all a bit stable. And then, we've got a bit of a spike later on because someone suddenly realized our security is going to have to be completely reworked. It's that sort of interaction. So it's unpredictable. Excuse me. In terms of what we do, I'll talk about activities in a minute, but people always want to know about artifacts rather than activities. So I'll talk about artifacts first. Obviously, the activities create the artifacts. But we have tended historically to create relatively top-down, relatively prescriptive design. Maybe collaboratively, hopefully collaboratively, but we tried to write down the schematic for all the moving parts, how they all fitted together. I think actually where we need to get to is definitely having architecture artifacts, whoever produces them, but they're less prescriptive and they're more guidance. We need styles and patterns. So an architectural style is a fundamental organization of a system. An example of a style is client-server, another one would be event-driven, another one would be Blackboard. You get the idea. They're those kind of level of patterns. We call them styles simply because they're the organization of the whole system rather than a solution to a problem in a part of a system. So what styles, we hardly ever use one, we'll use multiple ones. Which styles are we using in our system so everyone understands what kind of pieces are we going to have and how are they going to be connected together? And then patterns, how are we going to solve repeating problems, such as how are we all going to agree to do authorization the same way? And hopefully codify it in a library. But if that's not possible, let's at least have a pattern where we all agree how we're going to do authorization in the same way. We should make sure that we have principles for people that guide them on making their own decisions. If we just let people make decisions, and we haven't done any thinking about what's important, what's not important, the way that people should be thinking about the decisions, we can hardly blame people if their decisions are divergent. And I've tried this a number of times and thought, just sort of by telepathy, people will kind of converge their design decisions. They're part of the architecture after all. No, never happens, and it's totally unreasonable to expect it. We need to work on a set of principles that guide people into how we want the design decisions to be. And finally, we need to make sure we record our decisions. And the older I get, and the more systems and architectural problems I review, the more I'm convinced that actually the decisions are really, really important. And they're important for a number of reasons. Firstly, if we write them down and use an ADR or use a wiki page or do it however you like, ADRs are simple and lightweight. By all means, use them. If you record a decision, that forces you to think it out. Because everyone thinks they've decided as to the fact we're going to use gRPC and make everything synchronous. Everyone goes, yeah, we get all that. And everyone goes on and does it. And then somebody's in the group thinking, I'm still not quite sure why we're doing this. If you write it down, you really have to think that out, and you can critique it and say, that's not true, or I don't agree. It's also later it's quite important, because how many times do you move on to a system or something changes and you go, why on earth did we use a document-oriented database? And actually, no one's quite clear. Yes, it must have been a good idea at the time, but we've lost the reasoning. Why is it important to have that reasoning? Because it seems to be a bad decision now. Well, sometimes the problem that we're viewing right now that makes us want to change that blinds us to the fact that there are other forces in the system where actually that document database is maybe doing a good job. And that's where a well-written ADR from 4 years ago is really, really valuable to remind us of that. So that's, I think, what we're trying to get to is, rather than blueprints, there are models, but they're models of styles and patterns. They're principles to guide decisions across the empowered teams. And they're decisions so that we know our history of decision-making, and we have a rational, first, we've got the rationale, and two, we have a rational basis for future decisions and changing the old ones. And really what I'm trying to get to is an evolving shared design. So there is a design for the system. There's an old architecture tenet from the research community. Every system's got an architecture, you just may not know it. It may not be intentional, you may not understand it, but it's got an architecture whether you like it or not. So we're trying to be intentional and say, yes, the system has the design, we want it to be constantly changing, we know that's a fact, but really we want it to be shared. We want every delivery team feeling that they've got an equal stake in how all that cross-cutting stuff works. And even if they don't think it's perfect, even if it's not quite right for them, they acknowledge the fact that it's shared and it was the best decision at the time across all of the teams. Yes, it causes them pain, but they get the reason why, because actually it's better for 7 teams out of 8. Just a word on artifacts. This isn't anything to do with architecture, but it's obliquely related. I see a lot of documents, because we do a lot of reviews, and at my level in the firm, one of the things I do is I go into new customers, and they say, we've got this, how do I put it politely, this suboptimal system. What should we do? And I read a lot of documents. 2 things I notice, and this actually comes from someone called John Daniels. If you remember John Daniels, if you're very old, he was a pioneer of object technology. 2 things every document needs: an audience and a purpose. An awful lot of artifacts are written without any thought to given who's going to read it, why do they care? And it's very hard to write a good document, or for that matter, to write a good test. I've seen a lot of tests that appear to be written without any thought as to who was ever going to read it ever again, whereas actually your tests are your documentation, aren't they? That's what we tell each other. The tests are the documentation. And if they're not written thinking about who's going to read that documentation, they might not be very effective. So you've got to have an audience, you've got to have a purpose. And they need to be minimal, usable, significant, indexed, and checked. Music. I will confess, I originally only thought up MUS. Have you heard of Nat Price? He's the guy who wrote the Goose book with Steve Freeman. So he's a sort of big wheel in the Agile world. I gave a totally different talk about documentation using minimal, usable, significant at Agile 2015 in Edinburgh, and Matt came up after me and said, have I got a gift for you? He said, I've got 2 more that will make the acronym into music, and then everyone will remember it. So that's a gift from Nat Price. Make them as small as possible, and that's not normally the quickest thing to do, is it? It apparently wasn't Blaise Pascal, but somebody said, I had to write you a long letter, I didn't have the time to write you a short one. Often like that with documents. A brain dump is a lot quicker than a short, well-structured document, isn't it? It's a lot of effort. But the reason they need to be minimal is, 1, for the people reading them, because they don't want to read 40 pages, thanks very much. They'd like 2, with the real stuff in it. And secondly, if you're going to keep them up to date, a big 40-page document's a nightmare. 4 pages is quite manageable. They need to be usable. That goes back to the audience. So you want to serve automation testers with this API documentation. Will they understand it? And can they access it in a way that on their desktops, when they're writing automated tests, they can get at it easily? Is it significant? Is it worth writing down? I see a lot of documentation seems to be produced because someone thought there should be a document, or that this audience had asked for a document, but actually it'd just be better to go and read the code. And then the last 2 were Nat's genius. If you can't find the stuff, it's not useful. And my experience is relying on Confluence full text search. Much as, unlike Stefan, I rather like Confluence, but relying on Confluence full text search, I have discovered to my cost, is not an effective strategy at finding stuff again. And secondly, it needs to be checked. It needs to be checked twice. Once, when you write it, get someone else to read it. Can they understand it? Is it correct? And secondly, how often have you joined a new project, quite significant size, been running for some years, and what do you do in your first morning? Well, obviously you've got to have coffee with the team. But once you've had that, and they do a whiteboard sketch, don't they, of how it all works. And then they say, you should probably go and read the documents. And your heart sinks, and you go, I'm new, of course, I'll go and read the documents. And they say, where do I find the documents? What do they normally reply? Oh, it's all on Confluence. Oh, are they lying, aren't they? It's not remotely all on Confluence. But even what is on Confluence, they then go, it's all on Confluence. Oh, but don't read the part about messaging. We've changed all that. If you read the intro, I think the ending's probably okay, but the bit in the middle is all nonsense now. And you should know, when we access the database, we've introduced a document database alongside the relational one. Is this on Confluence? No. Anyway, we've got a very clever data access layer. Is that on Confluence? No. But you'll need to understand it. You know what happens is that if you don't check the stuff over time, it just rots. And then it becomes, you've just wasted your effort. And it's, it's a business, it's got business value, this stuff. So tell the business that without spending the time to make it better, you're wasting their money. Not yours, their money. So, if I've convinced you that doing architecture continuously is a good thing, that's all very well. It's a bit abstract at this point, isn't it? What do you actually do? Well, there's a good question. I do have an answer, luckily. There's 5 things. Provide leadership, focus on quality attributes, drive architectural decisions, manage technical debt actively, proactively, and implement feedback loops. By leadership, I don't mean being the project manager or being the scrum master. I mean, if you do that and you're good at it, I mean, great. You've got superpowers, because I can't do that at all. But leadership is important. It's all about technical concerns. Who's being the tiebreaker? Who's finding the technical consensus? Who's explaining to the teams that a decision is needed here? Who's making sure that people have done the research and they're actually thinking about all the trade-offs? I describe it as, you are the technical conscience of the team. Whoever you are, whatever your role, but you are the technical conscience. You're the one saying, if we do this now, I've got a fair idea what's going to happen. And everyone, you know what happens, isn't it? You're being unpopular, because everyone would like to do this and move on. They've had a 90-minute meeting already, thanks very much. And they all kind of look at you and go, yeah, we do now. Your job is complete. If the team decides they're going to continue with that flawed decision because it is the right thing to do, That's absolutely fine. But if no one stands up and says, this is the wrong thing to do and we all know it, it just floats by. As we said, Scrum teams are very good at delivering features. Well, hopefully. I mean, otherwise we haven't got good Scrum teams, but that's why we empower them, because they're good at this kind of thing. But there are a lot of system-wide concerns we talked about earlier, which just get forgotten in what are called the dash to features. And this has become because most product owners either don't understand the importance of quality attributes or are not goaled on achieving them. I know there are some of my product colleagues at Endava would now be jumping up and down at the back of the room going, it's completely incorrect. We always talk about it. We work with the architects more. And they're right. There are some who are really good at it. I've met a lot who really are domain experts. They know what features they need, and that's sort of it. So what do? They're the primary people who hold the Scrum teams to account. What do you know? The Scrum teams mainly deliver features. So there needs to be work to counterbalance that, whether it's in an architect or not. Senior technical people often have specialist knowledge. I'll bet every person in this room, in your organization, you know more about something technically than anyone else in the organization. In fact, you may know more about quite a range of things than anyone else in the organization. That kind of specialist knowledge needs to be nurtured and kept safe and used, not promote the people to be project managers and just hope that it exists by osmosis. And that's an important part of architecture work. And these trade-offs between difficult options is difficult. What was the quote yesterday? I can't remember it. I tweeted it, I can't remember it. But it was along the lines of, an easy decision that pleases everybody is a rubbish decision. All the good decisions upset somebody. I think there's a lot of truth in that. The way I've always described it as software architecture is a process of continually choosing the least worst option and disappointing some people all the time. And I've always found that. Driving architectural decisions, as we're talking about decisions, is not about making them all. And I think by now we've all agreed that. It's actually about empowering teams to make good decisions. Yes, there are some, but honestly, you know your teams. You know the people in them. You know that there are some decisions. Honestly, you'll try and make it look very collective, but you might just have to make it and bring people with you. But you haven't got time to make them all. So we've got to empower other people to make good architectural decisions. So make sure that they are understood. Get the principles together, drive them, make sure people agree with them, make sure they're the right ones, review them. How many violations of the principles have you got? Lots of violations of one of the principles is either a problem with decision making or a problem with the principle. So all this stuff needs done intentionally because Scrum teams are not going to do it by themselves. They just are not goaled to do it. And of course, making sure decisions are captured. Technical debt. Who in your teams manages technical debt? Project manager, architects, developers, testers, product owners, or no one? What does managing technical debt mean? Lots and lots of teams, it means going, that's a problem, and then raising a JIRA ticket, tagged technical debt, right? And how many JIRA tickets do you have tagged technical debt? It's a slightly concerningly long list, isn't it? And the problem is not that you've got a long list of tickets, that's just life. The problem is that in many cases, if you go to a team and say, oh, 94, gosh, that's quite a lot. They go, yeah, it's quite a lot. What do you think the impact is? What will that prevent you doing? Oh. What would it cost to sort them all out? Oh. We've got technical debt. You asked us to track technical debt. What's your problem? Well, my problem is that the only reason that we actually track it is because it allows us to reflect it back to the business and explain to the business or the acquirer, whoever you're working for, if you're in a product company, it allows us to reflect back to them and go, the liability that you're carrying is this, and it's got these implications. We went in to see a system not very long ago, and it had been internationalized at ridiculously rapid pace. It had originally been, I can't remember, a country or two. It had to go into another country. They didn't really have an internationalization strategy. Product owner went, it's all got to be done in 2 months, just get on with it. No real decisions as to how to do it. But in loads and loads of if country one then, if country two then else. You went, oh. And that was just recorded as a JIRA ticket. This is quite serious technical debt. And I mean, it was probably, perhaps was the right thing to do. I mean, I wasn't aware of all the business pressures they were under. It may be the right thing to do. There's a big implication. If you go into another country, it's going to cost you even more than it did last time to go into another country. And if that country is, for example, just pick a country, South Africa, and you're just starting out there, it's going to be really hard to make a business case to go in because the cost of changing all that code is massive. Whereas if you'd done it properly and you'd actually had an internationalization strategy with plugins, say, perhaps entering a small market would have been very cost effective. Now, as long as that's okay and the business goes, that's fine, we're not entering any more countries, that's a decision, we're going to live with it, that's a good outcome. It's not always repaying it, but it's managing it intentionally and particularly being able to understand what the implications are and often explain them to non-technical people, unfortunately, which I know is not always the easiest thing to do. But that's what we need to do because they've often got the money. Oh. And finally, feedback loops. We continually talk about feedback in software development. Agile came about largely as a reaction to lack of feedback in the non-waterfall process that everyone was using. The problem is that actually achieving feedback is a lot harder than it looks. The Software Architecture Metrics book that I contributed a chapter to about a year ago, that's a big theme in that one, is that lots of authors trying to give their thoughts on how to achieve feedback. And you read the chapters, there's more problems than solutions, really. Getting feedback from all of your delivery processes is difficult. Getting feedback from operation can be difficult. Knowing what to do with all of the data that you're collecting, turning information, can be difficult. Again, it's very unlikely anyone, other than people doing architecture work, are actually going to implement feedback loops to create effective information to drive change in the process and in the product. And that needs to be really intentional. So those are my 5 things that I think are important in architecture work today as we move into a more continuous world. And you will notice that modeling is not actually one of them. That's not because I don't think models have any value. It's a bit like Agile Manifesto-ish. I'm not saying throw out the models. What I'm saying is that these are the things it's important to be doing to achieve the outcomes we need. And you may well create models, particularly for quality attributes, or particularly if you want to manage your technical debt. You may well create models to support you in doing that. What I'm trying to avoid is modeling becoming an outcome in itself. So to conclude, the world has changed. Things like cloud and things like Agile and DevOps ways of working have allowed us to create these amazing digital platforms where we don't know the destination when we set off, and yet somehow, year after year, we keep delivering value to the business. If you look at where we started, when I started writing software professionally in 1990 with a C compiler on quite an early production version of Unix on a product called Tuxedo. When you look at how, and my colleagues in the business stream were writing Oracle forms. I kid you not, I really dodged a bullet there. When you look at how productive we were to what we can do today, it's just the cheek of people to complain that it's not perfect. It's just remarkable. It's been quite a journey. But the latest evolution to digital platforms has made things yet more complicated. And this has sort of produced a sort of implicit continuous software engineering approach. I write it on the slide with capital letters as if it's a big thing. It's not, just everyone's sort of doing it and hoping for the best. I think there's quite a lot of thinking to do about how we actually get better at continuous software engineering. But from the architecture perspective, which is really what I know about, there's a lot less value in upfront architecture. That certainly was a very comforting thing that we did a lot of when I started out. That led a number of people, I have come quite late to the party, but Murat and Pierre were there well before me, to identify continuous architecture as a solution. And the 5 things that I think are important to stress are to provide the technical leadership, focus on quality attributes so that they get delivered, intentionally manage technical debt so you don't end up writing off the whole investment after 3 years, making decisions as first-class artifacts and making sure good decisions get made, and then implementing feedback loops. It will be fascinating now to go through all of those 5. That's unfortunately a different talk. So maybe we'll do that one next year. Because what we're trying to achieve is to go from the architect being the historical purveyor of wisdom, the tablets of stone model, to the architect or the architecture team or the technical leads being trusted leaders and advisors who are empowering people to do good architecture work. Quite a few books. I will leave you to peruse them as you get time, because I'm just about out of time. There are a couple of people who are looking at this area. Continuous Architecture.info is the website for the Continuous Architecture in Practice book, which is on O'Reilly, of course, which I'm sure many of you have. A quick way to get it. Continuous-architecture.com, slightly confusing. There's nothing to do with us, but it's more people who talk about continuous architecture. It's the Michelin company in France and a consultancy, French consultancy, who've been working with them for a number of years on how they make their software architecture practices continuous. We sort of have friendly relationship with them, but they're not, it's not one unified thing, so they say some different things and we say some different things, but we're all headed in the same direction, which is how do we make architecture ever more important and ever more continuous in a digital age. Thank you very much.